Hey, um, so I got, yeah, I'm gonna like, show some like stuff. Uh, I have starting to work on, these, uh, variable power supplies. Um, as you can see, like, I haven't shaved, but I'm still trans. um, so this thing is a variable power supply I made. You just plug in your 9 volt that you use on here, and then a variable power supply comes out of this. Um, you can see here, this is just fucking just coming out of here with like a bolt to kind of hold it in place, because um, you know, uh, like, I could have made like a connector that like this for, and then a two male connector, but then you could. I just didn't want to, and also that would cost more money. It would cost a lot more money to do that, because then I would have to have two of these female jacks, and they cost like 75 cents each, and it's kind of a lot of money. Um, so that's why I just have it like that. So yeah, this has a knob, and then it has a switch that turns on or off there's a capacitor inside, which smooths the change in voltage, so that it's a bit smoother. And it can even be really, really smooth, like, to where if you go from full to zero, it'll take like about 3, 4, 5 seconds to get to zero. I don't actually know if this thing, if I even wired this to go to zero, but yeah. So I have just stop looking at my fucking hideous face for a sec. So I have a synth that I made here, and probably the best use that anybody can get out of this is using it with a synth, or using it with some kind of keyboard or something that has a 9 volt center negative power. Can even be used for things less than 9 volts. But for most effects pedals, it's not going to really do anything. Like, people get maybe a little excited with the idea of having a variable supply voltage, or sometimes they're called a dead battery simulator, and you know, the thing is, most pedals have digital uh, circuitry in them to just turn them off when they detect under voltage. So for the most part, a dead battery simulator or variable power supply isn't actually going to really do much other than just turn the pedal off. But I have here a few different pedals that we can try and see um, if they work. I have a bass overdrive that I'm not sure if it even works actually. A Moore Skyverb, and a Boss Harmonist pitch shifter, and we're gonna see, I guess, what ones the power supply works on, and I'm going to test my hypothesis, I guess, that for the most part, most pedals that you're going to get are not really going to do anything very interesting with a power starve. But you know, we'll see, I guess. So first, I'll try the Skyverb, because I have actually tested it, and I'm just going to run my synth through it to test it. So I'll connect the variable power supply to it here, and here is the variable power supply. And then let's see, this is output, and then input from the synth. So right away, the power starve is too low. It's not powering on the pedal. So we will turn off that switch and turn this all the way up. So yeah, now the pedal has power. So let's see. So the pedal is working now. Now I'm just going to slowly bring the power supply down, and we'll see what it does. And I'll just leave the synth on something so that it's something that, you know, you'll notice the sound of the reverb. Alright, there. So we barely can turn it at all before the pedal just stops putting out anything. That's because this is a digital reverb pedal, so yeah. Not much range. Let's turn it back on. I'm going to try the switch to turn the capacitor on for smoothing and see if that helps. Yeah, not much. The pedal pretty much just stops doing anything. Yeah, so for reverb pedal, variable power supply, not really doing much. And the digital error protection circuit is doing that kind of buzzing, really loud buzzing clipping sound, which is just the sound of the capacitor charging and discharging inside of it, because it can't tell if it actually has enough voltage going to it or not. So not really doing much. I am interested to see how this bass overdrive pedal responds, because it's less likely to be fully digital. So it might have a more interesting effect. Let's see. This is output, and this is input. Let's see, so I'll just run it at full power and see. So now there's no sound. I have a feeling this pedal is just fucked. Which I thought it might be anyway, so we will not mess around with that, because it seems to be something wrong with that pedal. So we will try the harmonist. Okay, so that's what the harmonist normally sounds like. It's a really good pedal. It sounds kind of digital and crummy, but whatever. So we'll try power starving it. Yeah, so this also seems to have digital error protection to protect from under voltage. It just turns off. We will try the smoothing to see if that helps. And the smoothing on the power supply does not seem to help really. So, as you can see, most pedals have under voltage protection that digitally just turns off the pedal if it's undervolted. So I can't really think of a way that someone might bypass that because the only thing I could think of was to add that smoothing capacitor, and it doesn't really seem to help. But one thing I haven't tried with that is to actually run the power supply, the variable power supply onto the 9-volt battery of the pedal. I guess we could try that. I'm pretty skeptical that it will make a difference, but we can try. What I'm talking about is actually doing a real dead battery simulator, which by putting the power supply onto the actual battery part of the pedal. So try that. Let's see, negative inside, positive outside. Yeah, not really surprising there. The battery power has the same error protection, so, and I would assume, this is a Boss pedal, and they kind of set the standard for stuff. So yeah, unfortunately, power starve for most pedals is not really going to do much. If you are thinking of buying a power starve dying battery or whatever you want to call it for something, what it will work on is like I said, something that runs on 9 volts or less DC power, and something like that would be a synth. This is a synth that I made, and I don't know, probably going to sell it, but if you have a synth, the way that I make my synths, there's no protection for undervoltage. If it gets undervoltaged, it just keeps working at the lower voltage. So well, I'll show you how it works for one of my synths. You kind of heard what the synth sounds like. It's just a pretty basic, hex Schmidt trigger inverter based synth. Sorry. So that's what this synth sounds like, and then if I put the power starve on it, it opens up a whole different dimension with things, because what a power starve for the type of synths that I build, like this one, does is it the Schmidt trigger response to voltage is kind of a bell curve, slightly skewed. It if you have it rigged up as a multi-vibrator, a stable multi-vibrator, it kind of goes the higher frequencies around 9 volts and above. So, and then as you go down in frequency, the frequency, as you go down in voltage, the frequency will decrease, and then it will, around 3.5 volts, start coming back up again to be higher. So it has a kind of nonlinear frequency response to voltage, which is cool, because then as you're adjusting the voltage supply, it's not a linear, it has different characteristics all along that voltage range. So I'll just leave it on this simple setting that I was using before, and just so you can get an idea for how the frequency response is so nonlinear and interesting. So with synths like that, it's pretty interesting because as you could see there, the knob for the power supply basically modifies all of the parameters on the synth at once. So that's pretty interesting. But yeah, I would go into more detail, I guess. I could just go into slightly more detail about why this situation is the way it is. Most digital circuits run on a crystal oscillator that runs at a fixed frequency. And if that crystal oscillator gets undervolted, it just stops working. And because it's a crystal oscillator is only supposed to go at one frequency, it only can go at one frequency. So, you know, there are sometimes you can circuit bend something with a crystal oscillator by modifying the decoupling capacitors that are connected to that crystal oscillator that determines the clock frequency for the microcontroller. But really, that's not. That's usually just introducing a DC offset into the clock circuit for the microcontroller, rather than actually changing the frequency of the clock. And changing the frequency of the clock might be interesting. There are likely there's likely to be different parts of the microcontroller that require a certain clock frequency in order to function, though. I haven't really gotten into. I've known some people who have circuit bent things that run on a crystal oscillator instead of just simple RC resistor capacitor multivibrator. And apparently it leads to interesting effects, but by just swapping out the crystal oscillator with a crystal oscillator of a different value. So you could try that with different things, but that's something that you'll have to actually get inside of here if you want to do it with a pedal. And at that point, you may as well just circuit bend to the pedal. But circuit bending pedals is kind of a bitch in general because Boss is a corporation. That should just kind of explain itself. So yeah, this has been kind of my little stream about power starve, when you can use it. It's interesting. When you can't, which is most of the time, it just goes to show you the problems from digital effects, and I just also should make I'm not gonna get into too much of a rant about it, but with digital stuff, I like digital stuff a lot, but people who design digital stuff, I don't like. I don't like the engineers that design things like this. For a lot of reasons, but mainly because they tend to be too prudent, I guess, in their designs, because for most digital circuits, really, the way things are designed is, instead of letting things malfunction in any way, just turn it off. Just turn the entire circuit off and render it entirely inoperable. And that is frustrating from a circuit bending point of view, because then you can't circuit bend stuff really, because it just turns off. It's not allowed to malfunction. From a point of view of somebody who just wants to repair electronics, it's also annoying, because malfunctions can give you an idea of how the thing is working. And if you need to repair something, it's sometimes useful to make the thing malfunction on purpose, because then you can get an idea of how it is malfunctioning and why it's malfunctioning, and that will help you in repairing the thing, because there are certain ways that different pieces of electronics will malfunction in pretty predictable ways. And based on what you do to a piece of electronics, it will malfunction in a certain way, if the design is a certain way. It just makes the process of repairing things a lot easier. But obviously we don't make electronics to be repaired, which in my opinion is not good. We just make electronics to be used, and then once they get slightly malfunctional, just throw them away. And I just don't like that on principle. But so that's my little talk about problems with the way digital circuits are made these days. Anyway, alright, hope you